Good morning. Okay. Oh, she is on a meowing rampage. For today, we're going to cover pedigrees. This is going to be called pedigree analysis. So pedigree is a visual representation of a trait being passed down from one generation to the next. So it's not necessarily like a family tree. Typically it's related to family, but so like if I wanted to draw my pedigree for myself, it would be difficult because I'm adopted, and so I don't know the physical features of my parents and their parents, so on and so forth. So what pedigrees show is they just show reproduction. They don't necessarily show marriage, and they only show relationships between born males and born females. So it's very biological. It's not showing, like I said, it's not showing marriage. It's just showing reproduction. It's showing offspring, and it's showing traits being passed on. So in pedigrees, we use really particular symbols, and there's only two symbols we really use. So we're going to be using circles, and we're going to be using squares. Now, if you see a circle, those represent individuals born as female, so they're biologically female. Okay, and then all squares are representing our males. So if we want to show that a male and a female have reproduced together, and a lot of people say like marriage, but it doesn't have to be marriage. It just means to be like they've been sexually interacting. You draw them on the same line, and then you connect them with a horizontal line. So this is representing reproduction. Typically on a pedigree, you don't show the reproduction unless they produced offspring, because it's not information that we need. Because if they don't produce offspring, then we are not going to be able to investigate how a trait was passed on. So horizontal line connecting them, that's reproduction. If you want to show their offspring, you do a vertical line down from that reproduction line, and then you show all their offspring below. So let's say this couple had 3 offspring, and how you organize them on a line is by their age. So like this showed here that the man was older than the woman, and then down here, let's say their firstborn child was a boy, their second-born child was a girl, their third-born child was a girl. So you just go in order of age. This would be their eldest, and this would be their youngest child. So these are showing the offspring. If you see circles and squares that are unshaded, it means they don't carry the trait that we're looking at. So for every pedigree, you can only look at one trait at a time. Typically, we look at diseases and disorders just because we want to see like, how is this disease or disorder being transferred in your family line? And is it possible that you could pass it on to your children? And so if you see an individual who's shaded, it means they're affected. So it means that they have the trait in question. So like sometimes people make pedigrees like blue eyes. Does that mean you have blue eyes? But like on this pedigree worksheet that you're doing today, the first one is Huntington's disease. So they're tracking the presence of Huntington's in this family. So this would mean this individual has Huntington's. If you see an individual that is half shaded, it means they're a carrier for the trait. If you're a carrier, that automatically means you're heterozygous. And that also automatically means that the trait is caused by a recessive allele. So people who are carriers, they carry the disorder. They don't have it, but they carry it so they can pass it on to their children. The last thing you might see is you'll see a symbol with a line through it, like a diagonal line. Sometimes they draw the lines differently, and this just means that the person is deceased. So sometimes you'll see someone who's shaded and they have the line, and that might mean that being affected caused the death, and so it would be like a lethal disease or disorder. Okay, so for every pedigree, essentially you're just trying to figure out what's the mode of inheritance for the trait in question. And so if you look on your worksheet, they're going to be asking you specific questions about specific individuals. And so the way that we organize and kind of talk about individuals here. So instead of me having to say like second row, third circle, we identify our generations first. So this would be all the same generation lie on the same line. So generation 1 would all be up here, all of their offspring would be down here, and then like these guys' offspring would be on the next line. And so we denote the generation by a Roman numeral. And then in each generation, we number each individual with just regular numbers. So 1, 2, and then we start back down here, 1, 2, 3. So if I asked you like, what's the genotype of individual generation 2, number 3, we would all be looking at the same individual, and then we would all know whose genotype we need to figure out. Okay, next, there are many possible modes of inheritance. And so I'm gonna go over like patterns you need to look for, but sometimes you can't definitively say what mode of inheritance this is showing. So there might be a couple possibilities. So don't get frustrated if you can't like really figure it out. Just put all the things it could be instead of figuring out which one it is. So for patterns of inheritance, there's actually 4 different types. So 1, skip a couple lines. 2, skip a couple lines. 3, skip a couple lines. 4. So there's 4 different modes of inheritance. The first one is called autosomal dominant. We're going to do these first 2 at the same time. So we have autosomal dominant, and then the second one is called autosomal recessive. Okay, so the autosomal part of this modes of inheritance just mean that these, the trait is carried on a somatic chromosome. So the trait will be carried on chromosomes 1 or through any of them through 22. Okay, so I'm going to make a note right here. So carried on chromosome 1 to 22. So remember, we have 23 pairs of chromosomes. So it's the trait we're looking at would be carried on any of those. And then our last pair, 23, will be our sex chromosomes, and those ones are going to fall down here. So autosomal dominant and autosomal recessive follow simple rules of dominance, so like just straight up Mendelian dominance. So that means for autosomal dominance, the individuals that would be affected or have the trait would be anyone that has a dominant allele. So it would be anyone who's homozygous dominant or heterozygous. So if you're either of those genotypes, you would have the trait if the trait is displaying an autosomal dominant inheritance pattern. For autosomal recessive, there's only one way to be affected. It would only be homozygous recessive individuals. So if you have this genotype, then you are afflicted with the disorder or just the trait. So with autosomal dominant and autosomal recessive, there's 2 really specific patterns you're trying to look for. So you shouldn't just be like guessing willy-nilly. You should be looking for these really distinctive patterns. So for autosomal dominant, the pattern that you're going to be looking for is, and I'm just going to be drawing one child, you're going to be looking for 2 parents who created an offspring, and you're going to be looking for 2 affected parents who produced an unaffected offspring. Okay, and the reason you're looking for this really specific pattern is because this would tell you that each of these individuals would be heterozygous, and then that could possibly create a homozygous recessive offspring, because if you do your Punnett square, you're taking our 2 parents, so there's their gametes, here's our fertilization. Okay, so it's possible that they could have an offspring who's homozygous recessive and therefore will be unaffected if this is an autosomal dominant. So this is the pattern you're looking for. Are there two parents who are affected, and did they have any offspring that are unaffected? And that would kind of help you figure out, oh, it must be dominant because that individual must be homozygous recessive, and then that means that these guys must be heterozygous. And then you can kind of figure out the other genotypes as you go. For autosomal recessive, you're looking for the opposite. So you're looking for two parents who are unaffected who have an affected child. Okay, and so what this would tell you is if these two parents are unaffected, that means they must each have at least one dominant allele. And then if they had an offspring who's affected, they must be heterozygous. Their offspring must be homozygous recessive, because this is a autosomal recessive trait, and they could have this offspring who would be affected. And so you're looking for the opposing pattern, because if it's autosomal recessive, if these guys are both homozygous recessive, so shaded, all their offspring would be shaded. Okay, so if you see shade, and then everyone is shaded, then that probably means it's also autosomal recessive. Okay. The last two are what we call sex-linked inheritance. Let's turn our paper 3 and 4. These are all sex-linked. So that means they're carried on chromosome either the X or the Y. This is pair 23. Okay, so if you're a female, since we have XX, we can only be afflicted by X-linked traits. If you're a male, because you have XY, you can be afflicted by both X and Y-linked traits. And it's actually easier, simpler for males to be affected than females. So the first type is called X-linked. And then the second type is called Y-linked. So we're just figuring out, is it carried on the X or the Y chromosome? These ones are a bit harder to pick out because sometimes it'll look like one of these, but it's actually one of these, okay? Because when you look at X-linked, you're looking at, is it X-linked dominant or recessive? So let's say you're looking at a pedigree. You figure out, oh, this is caused by a dominant allele. Then you also have to look and see, is it possible that the dominant trait is carried on the X chromosome? So when I look at pedigrees, I usually start here. I just try to figure out, is it dominant or recessive? And then I'll look and see, could it be X-linked? Could it be Y-linked? Okay, because then you could have two possible answers for your pedigree. You would say it's autosomal recessive or it's X-linked recessive, because you have to pick, is it dominant or recessive here. Same thing for Y-linked. You're going to figure out, is it dominant or recessive? Okay. So up here we kind of went over the genotypes to be afflicted, and let's do the same thing down here. So if it's X-linked dominant, that means the X chromosome. So you always just start writing the sex of the individual. So they're either XX or they're XY, right? So they're either female or male. If it's an X-linked dominant trait and the individual is afflicted, that means at least one of these X's need to be dominant. So the way that we write the dominance and recessive is we do them as exponents. So we'd have X big A, and then they could either be X big A or little a here. So they could either be heterozygous for that trait or homozygous dominant for that trait. If you're a male, you have to have X big A if you're affected, because you only have one X chromosome. If it's X-linked recessive, then it's going to be X little a, or X little a, Y. So we're not writing anything on the Y chromosome because it's not a Y-linked trait, it's an X-linked trait. So you only need to show that trait on your X chromosome. So what I'll typically do is I'll figure out, is it dominant or recessive? And then I'll start writing the genotypes like this, and I'll see, okay, if these two individuals had an offspring, so let's say this individual and this individual had an offspring. So we had X little a, X little a on my Punnett square. and then I had X, big A, Y, okay? And let's say that it's a recessive trait. We want to see, could these two individuals have an affected offspring? So you start with your sex chromosomes, right? So in this box, we'd have X, X, so female. We have big A, we have little a. So if this is a recessive trait, she'd be unaffected. Over in this box, X, X, so female again, big A, little a. So she'd be unaffected. Down here, X, Y, little a. So we have an affected male, X, little a, Y, an affected male. So what this is showing that if these two individuals have offspring, 100% of their boys, their males, will be affected. So then you're gonna look for that pattern. Like, do you see a mother who's affected who has all affected sons? So that's the specific pattern you're looking for. Or none of her daughters have it, because it's difficult to pass on to your daughters if the father's unaffected. So for X-linked, you kind of have to, what I typically do is I'll just write out the genotypes on my pedigree just to see, like, could it be X-linked? Like, could this be showing an X-linked dominant or X-linked recessive? And like a lot of times it's not. A lot of times it's just like plain old autosomal. But there is a couple specific patterns you can look for. So you can look for moms who are affected or carriers. So they could either be shaded or half shaded, and then all of her sons are shaded. So if you see this pattern where there's a mother shaded, all the boys are shaded and the females are not, the daughters are not, then that might be showing an X-linked. So this one you kind of have to like write out your genotypes and see, like, could this be representing X-linked? For a Y-linked trait, if it's Y-linked dominant, so remember Y-linked can only happen in males, so we can only have XY, and they would just have the dominant allele because there's only one Y chromosome. If you have it, you have it. If it's Y recessive, then XY, they'd have the recessive allele. If you have it, you have it. So like for males, they literally only need one copy of the allele to be afflicted by the disorder. So like color blindness is an X-linked trait because it occurs more often in males, but you inherit it from your mother because it was your mother's X chromosome that caused it. Okay, so for Y-linked, the specific pattern you're looking for is you're now looking at the boys. You're looking at the father. So if you see a pattern where a father let's say is a daughter, a son, a daughter, a son. If you see an affected father, okay, that automatically means all his sons are affected because the only individuals who get the Y chromosome from this man, this Y chromosome, are his sons. So if his Y chromosome is affected, that means all of his sons' Y chromosomes are affected because they have no option but to get that Y chromosome. So if you see that pattern where it's just like literally just males being affected, then it's going to be Y-linked. And a lot of times with Y-linked, it's really hard to determine. I can't determine if it's dominant or recessive. So you would just say like, this could be Y-linked, and then you wouldn't say if it's dominant or recessive. Okay, so I wanted to show you your worksheet just to kind of see what you're doing. Oh, I'm so coffee this morning. Okay. Zoom out. So if you look here, you're going to be looking for specific patterns. Now, luck would have it that the first one on your worksheet doesn't have any of the patterns that I showed. How exciting. But it does have this right here. When you see a cluster of individuals like this where none of them are affected, it most likely means that they're all homozygous recessive, right? Because if these individuals are recessive, these individuals are recessive, little a, little a, little a, little a, then automatically all their offspring have to be little a, little a. So like the chances are high that to be unaffected, it's recessive. Can we definitively say no? Okay. But then up here, you can kind of figure it out. If all my unshaded are little a, right? So if this individual is little a, then this individual must be big A, little a, because they had unaffected offspring right here. And then you can kind of figure out their genotypes as you go. So like, look, would have it, that one doesn't show any of my patterns. So sometimes you do just have to look at it and figure out what's the most likely. And then you'll see here there's other questions like which members are afflicted with Huntington's. And so you would say generation 1, so Roman numeral 1, individual 1. And you just write it like this. So you do the Roman numeral first and then the, I don't remember the name of those types of numbers, the regular numbers after. So if you look at this one does have one of my patterns. So if you look here, we have a female, we have a male, non-affected, and they have affected children. So that would show that this is an recessive or autosomal recessive. And then you just have to look, could it be sex-linked? I will say most of these questions just ask, is it straight up dominant or recessive? They don't ask, is it autosomal or sex-linked? So that makes it a bit easier. And then you're trying to figure out the relationship between these two individuals. It's their first cousins. How awesome. Down here you can see the example of carriers. So all these females are carriers. I think this one is showing color blindness. So most of you already know color blindness is already X-linked, but just write it out and just make sure it kind of follows the pattern of inheritance. You have another one down here. So you have 2 unaffected, and then you have affected children. So you're just looking for those really specific patterns. And then the key is down here in case you need help because you get stuck. Okay guys, that's it for pedigrees. I think this has been like my shortest video of all time. All right, I'm gonna make a video soon on how to access your AP tests because they kind of came out with some instructions and stuff. So I'm gonna do that video for next week because AP testing starts the week after. So I just want to make sure you're all ready for your other AP tests that start that first week of testing. So I'll make a video that kind of walks through how to access your test and like what to do if your internet goes out on the day of and like stuff like that. All right, guys, I'll talk to you later. Bye.